Hey everybody, it is 2 a.m. right now and I am exhausted, but I want to record this video for you so that you can get started with rates and we're not wasting too much time here. We have a lot to cover still, so let's get started. You should be on, I think, page 19 in your packet and ready to go. So there are three things over the next couple days that you're going to be able to do. First one is you should express rates using words and symbols. Yes, you should be able to identify, describe, and record rates from real-life examples. You're going to know a lot about those, and they're pretty important in life. And lastly here, you're going to be able to solve problems using rates. So that is what we're focusing on. The first part of your packet there on page 19 should have a table that you fill out and you write definitions. So rate, the definition is right here. It compares two quantities measured in different units. What that means is something like you have dollars per grams, or you might have beats per minute. Whenever you hear per, you know that per is division, so you're comparing two different kinds of quantities. Unit rate over here, here's the definition: a rate in which the second term is 1. That means in the example here, like 20 kilometers per hour, that's actually 20 kilometers per 1 hour. All right, so the second term right here, that is 1. 20 kilometers per hour is 20 per 1 hour. 64 beats per minute is 64 beats for every 1 minute. It's the same thing, it's just more simplified. That's what a unit rate is. Unit price, a unit price is a unit rate used when you're shopping. And this, like if you go to Superstore, you go to any grocery store, you're going to see this all the time. You can see an example down here. It says unit price, $2.19 per 100 grams. It helps you compare things to find out the value of the items that you're buying. So you usually see it in 100 milliliters or 100 grams, and that just makes it easier for you to compare what's cheaper or what's overpriced or whatever. Over here, did you know? Speed is unit rate. That compares the distance traveled to the time it takes to travel. So distance over time. When you go into high school, you're going to be dealing with that a lot in science classes. Distance over time. And math later too. So speed is often measured in kilometers per hour or km over h. Okay. So example 1. We have an example here, and then I think there's, if I remember correctly, there's one that you have to do yourself, a show you know, so make sure you're paying attention here. Ruby-throated hummingbirds and monarch butterflies travel similar paths across the Gulf of Mexico. The distance is just over 800 kilometers. That's important. It takes a hummingbird 18.5 hours and the monarch butterfly 41.6 hours to cross the Gulf. All right. So the first thing we have to do is estimate. I don't know why I crossed that off. Estimate. So we're estimating the speed of the hummingbird and the butterfly. If I'm estimating, I want nice, clear numbers. So I have 800. That's pretty good. 18.5 isn't a great number. I'm going to change that to 20. So whatever I get, I know that I increase that a little here. And 41.6 is pretty close to 40. This is just estimations, so if we have numbers that are pretty close, then it'll work out very well. Okay, so estimating. If we have 800 kilometers and 20 hours, remember that the speed was kilometers per hour. So that means I would do 800 divided by 20. And you should be able to do this in your head, because you're looking at 8 and 2, and if I multiply 2 by 4, I would get 8. So I'm looking at 40 here. 20 times 40 would be 800. So I'm seeing that that would be 40 kilometers per hour. Okay. And I got that by doing 800 divided by 20. The other one I have is 800 divided by 40. Well, I just did 800 divided by 20 is 40, so 800 divided by 40 should be 20. So 20 kilometers per hour. These are just my estimations. They should be fairly close, but they're not going to be exact. So now we actually want to do the calculations with the real numbers. So hummingbird. Hummingbird first. We were doing 800 kilometers except this time it's not an estimation. We are dividing 800 kilometers by 18.5 hours. So 800 divided by 18.5. You can look over at the calculator on the left side of your screen there. I'm going to do it there. 800 divided by 18.5 gives me 43.24. I'm just going to stop there. Okay. And then I have the butterfly. The butterfly is 800 kilometers divided by 41.6 hours. Okay, same thing. Look at your calculator over there. 800 divided by 41.6 is 19.23. And I left out the units here, but remember, we're doing kilometers per hour. So this is 43.24 kilometers per hour, and this is 19.23 kilometers per hour. Now our estimations were 40 and 20. It's pretty good. Okay, moving on. This one is a show you know, and you should have a blue box around that, which means that you need to do this on your own first. So right now I'm going to have you pause the video, and you're going to come back and just resume it when you're done to check your answers. Okay, so I'm assuming you did your work because you always do, right? A. Brandon runs 150 meters in 25 seconds. We are looking for the unit rate, which just means you divide it through. So you have 150 meters and you have 25 seconds, and you should have gotten 150 divided by 25 gives you 6 meters per second. Now for B, you have Kira. She is earning $88 for working 8 hours. So that's going to be dollars per hour. That's her hourly wage. It's also the unit rate. 88 divided by 8, well, that's an easy one. That's just 11. I don't even need my calculator for that. So it's going to be $11 per 1 hour. C, cat food costs $9. Whoops. Cat food costs $9 for 5 cans. I don't really know what abbreviation to do here, so I'm just going to write 5 cans. So we're trying to figure out how much each can individually is going to cost, and that is 9 divided by 5, and it gives me 1.8, which is $1.80 per can. I can just write per can? Sure, I'll write it like that. $1.80 per can. Okay, moving forward. Example 2. This is one we're working on together. Example 2, comparing prices. This is useful stuff for when you're shopping for yourself in the future. All this unit rate stuff is going to save you a lot of money. Brett went to the grocery store to buy his favorite brand of orange juice. He found the following container sizes and prices. Which container of orange juice is the best buy? Well, you have this one. It says it's 414 milliliters for $1.69. This is 946 milliliters, almost 1 liter, for $2.99. And you have $1.89 liters for $5.49. So remember, when I am comparing these, I am looking for dollars per milliliter or liter. I'm going to say milliliter. They all have to be the same unit. This one's in liter. So 1.89 liters, we need to convert that into milliliters, which means it is 1,890 milliliters. Okay. So if we are comparing these prices here, we just go like this. $1.69 divided by 414 milliliters. And then here we have $2.99 divided by 946 milliliters. And this one we have $5.49 divided by 1890 milliliters. Okay, so what do we get for each of these? It's going to be an ugly number because it's going to be our unit rate. And I'm going to show you a trick right away on how to make it a little less ugly, and it's the kind of thing you'll see in the stores. But let's just do it at the unit rate for now. So 169 divided by 414 gives me a really ugly number of 0.00408. I'm going to put a couple extra in there just because we're going to be comparing really small ugly numbers. Okay, the next one, I have 2.99 divided by 946, and that gives me 0.put a line through so we don't get confused. 0.003161. All right, and the last we have $5.49 divided by 1890, and we get 0.002905. All right, those are pretty ugly numbers, and it's really hard to tell what it all means. But remember that it is dollars per milliliter. Dollars a pretty big thing compared to a little tiny milliliter, and that's why we have these really weird looking numbers. It would probably be nicer if it was like cents per milliliter, but we don't really work so much in cents. So there is something that we do in like grocery stores and stuff we'll do that isn't unit rate, but it's very similar. And that's right here. So I've laid it all out pretty similar to what we had in the last one, 169 over 414 and all this. But one thing I want to point out is these arrows here that I put, there's a trick. And grocery stores like to show you in 100 milliliters or 100 grams, like I showed you before. And the easy way to get there for each of these is just to divide by, well, in this case we have 414, so we would divide by 4.14 on both the top and the bottom. And the reason I'm doing that is because if I divide 414 divided by 4.14, it gives me 100. Okay, so I don't have to worry about that. It's always going to just be 100. And if I divide 1.69 divided by 4.14, I don't know what that is. Let's find out. 1.69 divided by 4.14 is, oh, that's much better. 0.4, I'm just going to say 41. So 41 cents for every 100 milliliter. That's a whole lot nicer than what we had before, which was like 0.00408. I don't know. Let's go back. What was it? Yeah, that's what it was, 482. So you can kind of see where the other ones are going to go. 0.003161 and 2905, 0.002905. So if I look at these ones, I divide by 9.46, I get 100. And here I also divide by 9.46, and I will get a much nicer number. 2.99 divided by 9.46 gives me 32 cents. 0.32. So if those are in dollars, that's a lot easier to read. And that one will be 0.29 cents. That's a lot easier to read, and this is what you're going to see if you look at those product tags, and that's what's going to be useful to you. So now we're on to a show you know, and you're going to do the same thing. You have a brand of salsa sold in each of these sizes, and the sizes are 425, 642, and 1.7 liters. They all need to be milliliters. So compare the prices. Remember, you're looking for your cost per milliliter, and show your work to find out which is best in terms of value. So you're going to do that now. Pause your video and Okay, so you should have had a chance to go through this now, and I'm hoping you tried out that trick per 100 milliliters. If you used unit rate, it's going to work just fine too. It's just going to be really ugly numbers. But I'm going to try with that technique there. So per 100 milliliters for each of these. I've already laid it out. I've converted my liters into milliliters. So they're all good there. And remember, I just look at these bottom numbers, 425, so I'm going to divide the top by 4.25. That's my little trick there. So 3.44 divided by 4.25 gives me 81 cents, basically. 0.81. And here, for 6.29, I am going to divide 6.29 by the 6.42. So 6.42. And that gives me 0.98, almost $1. And the last one here, I have 15.49, and I'm going to divide that by, oh, I was doing, okay, 2 decimal places, so that'd be 17. If you did 1.7, you would have got this wrong, and hopefully you did not do that. Or if you did, you would have got a number that doesn't make a whole lot of sense. So hopefully you thought about that and went back. What would you have gotten? You would have got like $9 per 100 milliliters if you did it the other way. That wouldn't have been good. All right, so looking at these, it looks like the cheapest one is actually, wow, that was a really bad circle. Let's try that again. This is the cheapest one in terms of value. You are only paying 81 cents for every 100 milliliter. This is the most expensive, and this is the second best. This is the worst right here, just based off of our unit rate or the price per 100 milliliter that you worked out. Okay. Oh, I just have a bunch of pages doing the same thing. Great. All right, moving on into your notes packet, you have a section that talks about common rates that you need to memorize. I'll just go through these and you can write them in your list in whatever words you want to use. They're important things in life that you just have to know. You have a heart here per minute. That's just your heartbeat, your beats per minute. That's pretty important. If you have 0 beats per minute, you're probably dead. Or, I don't know, frozen? I don't know. Anyway, we have kilometers per hour. So this is your speed. Some other places you might have miles per hour or meters per second. There's a lot of different ways we can represent speed, but you'll see kilometers per hour most commonly here. Fuel efficiency, if you want to determine how efficient your vehicle is doing on fuel, you have like liters per 100 kilometers, or in some other countries you might have like miles per gallon. Okay, it's all the same thing. They're all just rates. And here we have dollars per item. We've already looked at a few of those. Cents per item, and bulk food. This is the one that we've been using most frequently because it's very valuable to know this stuff. Bulk food is dollars per 100 grams or dollars per 100 milliliters, that sort of thing. Okay, I think we're actually just about done. Okay, I'm not sure if this was something that you do on your own. I think it was not. Let me check real quick. No, it was not. Okay, so we'll do this one real quick. The thing we got to remember for these is some of them are those common ones that I'm talking about, the common rates. So you want to make sure that you are representing them in the ways that make sense. And you'll see what I mean in a second. So typing 126 words in 3 minutes. 3 minutes, 126 words. Well, that means I have 126 words over 3 minutes. But I'm quite certain, oh, I lost my calculator there. That's my bad. I'm quite certain that we can actually divide that, right? 126 divided by 3 is 42. So if we look at our unit rate there, it actually works out very nicely. We have 42 words per minute. Okay. Swim 300 meters in 1 minute and 40 seconds. Well, 1 minute and 40 seconds, we kind of need that to be all in one thing. That's minute and seconds. So we just want, is that 100 seconds? So 300 meters into 100 seconds, that would basically be 3 meters per second. 300 meters, 100 seconds. So zeros cross off, so that's 3 meters per second. That's really fast. Who can swim that fast? Jeez. Okay, gummy bears. 200 grams of gummy bears for $2.50. You could do this as a unit rate, and you could just do $2.50 divided by 200 grams and get some ugly number. But it's way better to just do it in terms of 100 grams to do that bulk money thing, because that's a common rate that you're going to be working with. And I know just looking at that, 200 grams to 100 grams is halved, so this is going to be $1.25 for every 100 grams of gummy bears. 35 beats in 15 seconds. So I have 35 beats in 15 seconds. I want my unit rate here. That's not going to work out very nice, is it? 35 beats in 15 seconds. Well, let's do the unit rate. Let's see what happens. So 35 divided by 15 gives me 2.33 repeated beats per second. I could also just write beats per second. Okay, $8.40 for 12 tickets. This is dollars per item. So I want to find out how much each individual ticket costs. $8.40 divided by 12 gives me, I don't know, it gives me 70 cents per ticket. What kind of tickets are these? That is really cheap. And $62 earned in 4 hours. So how much money are you making for every 1 hour? Well, you will get that by dividing 62 by 4. 62 divided by 4 is $15.50 per hour. Almost done. 2 more. 6 meters of fabric cost $45. Wait a minute. When we're doing price, when we're doing the cost of an item, shouldn't the dollar amount come first? Yes, it should. $45 for every 6 meters, so we want to know how many dollars per meter. So these are like swapped. How tricky. That is so tricky. Okay, so 45 divided by 6. You should know this by yourself in your head, mystery, but it's 2 a.m. Oh yeah, there we go. That makes sense. $5 for every meter of fabric. And lastly, and now I'll be able to go to sleep, we have 5 hours to fly 3,750 kilometers. Same thing. These are swapped, right? We want kilometers per hour because we're talking about speed. Kilometers comes first, and then hour. So we want to do 3,750 kilometers over 5 hours. And that one I cannot do in my head right now. 3,750, I can't do anything in my head right now. 750 kilometers per hour. What is it, an airplane? Yeah. Okay, that makes sense. Okay, I think that is it. Yes, it is. Good. All right. Good night. Have a good day. I'm out.